See here you can see that module 6, okay, introduction to fresh air calculation. So here what are all things we will discuss? We will discuss about air contaminant, then air change per hour, then we also will calculate, we also understand how to calculate fresh air and exhaust air calculation, then understanding of thermal wheel, horseshoe pipe, then heater and humidifier. Okay. First of all, why that fresh air is required? Basically to remove the contaminant. Okay, there are lot of air contaminant inside the spaces. Okay, so here you can see chapter 11 in one of the ASHRAE handbook, you will find air contaminants. Okay, air contaminant, you can say that air contaminant is a concern for ventilation engineers when it causes problem for building occupants. Okay, so there are lot of contamination inside the spaces. Okay, because it is always recirculation, correct? When you have an air conditioning system, it is always recirculation. You will not have any fresh air from outside. If you don't have a proper fresh air, there are a lot of problems. Okay, so you can say that air is composed of mainly of gases. The major gases component of clean air or dry air near sea level approximately 21% of oxygen, 78% nitrogen, 1% argon, and 0.04% carbon dioxide. So this is the normal air, okay, like fresh air. Okay, so when you have a again and again, if you have a recirculation, what will happen? There are a lot of contaminants. So what are the lot of contaminants? You can see here there are dust, fumes, smokes, okay, and you can say that mist, fog, smokes. Okay, there are a lot of contamination here. It is explained, like you can say sometimes there is a smokes, okay, and sometimes there is a biological origin also. When you have a continuous recirculation, you may have a bacterial, fungal formation, okay, because you don't have enough proper fresh air from outside. Okay, and also you can see that contaminant that present particular problem in the indoor environment include allergens. You can say sometimes allergy like because of the dust mite or cat antigen or tobacco, smoke, radon and formaldehyde. Okay, so these are the things. It's as actually the contamination. That is why we are going to have a proper fresh air. Okay, and also you can read this particular article. There are solid particles like dust, fumes, okay, bioaerosols, bacteria, and you can say that liquid particle like mist, fogs. Okay, then you can say complex particle like you have a smokes. Okay, environmental tobacco smoke. So these are the causes of contaminants. Okay, also you can see that the contamination the particle sizes. Okay, like human hair, skin flakes, observed dust in air, common pollens, then bacteria. Okay, tobacco smoke. There are different type of particles, right, in the fresh air. Sorry, in the contamination air. Okay, here also you can see the table with sizes of indoor particles, like different particles, like you can say hairspray, oil smoke. Okay, then you have a coal dust. Okay, there are different particle sizes. Okay, so that all we are going to have a filtration in the fresh air handling unit. Then here also there are bacterial contaminations, gas contaminations. Okay, you can say that harmful effects of gases contamination. What will happen when you have a contamination inside? When you don't have fresh air inside, what are the causes will happen? So you can say that there are irritations. You can say bad smell. Okay, damage to materials. If you don't have proper fresh air. Okay, you can say that there are different contaminant. Okay, like there are different gases. Okay, carbon monoxide, carbon dioxide, which normally we have in our home. Okay, then you have different type of gases. Okay, we'll have that much of contamination inside. Okay, so this contamination we are going to remove the contamination from the space by providing fresh air. Okay, you can say that sometimes volatile organic components, like if you know that there are some paints. Okay, in the paint also you have some bad smells, right? Maybe if you know there are new homes, when you enter inside the new home, you feel like discomfort, okay, because of the volatile organic compounds. Okay, so like that there are this article basically for explain about the contaminations. Okay, so that is why we are going to have a proper air change for each and every building for the proper ventilation. Okay, you can say that the air change per hour. So you can say that air change is the process of replacing the stale indoor air with the fresh outdoor air. What is stale indoor air? When you have a recirculation, what will happen always? There is a contamination inside. So that contamination you have to replace it, correct? With fresh air. So that is why we are going to provide the fresh air ventilation unit. So normally, uh, when you talk about in early conditions, in early stages, normally what they do the ventilation based on the air change per hour method. Okay, so the air change rate or air change per hour provides the number of times the entire volume of the conditioned space is replaced by fresh outdoor in 1 hour. Okay, so when you say 4 air change per hour is nothing but that means, say for example you have a one space like say 1 meter cube. Okay, so per hour you will have a 4 meter cube of air will be replaced inside the space. So that is called 4 air change per hour. If you say 12 air change per hour, that means 12 times you will replace that particular space. So that means 12 meter cube of air you will replace per hour. Okay, so that is why whenever you say air change per hour, how many times you will replace with that particular volume. Okay, so this is called air change per hour. Okay, so different spaces you have a different air change per hour. Why? Because different spaces have different contamination, correct? Say for example if you go to bar, you have a lot of contaminations because there some people they smoke, they use alcohol, so you have a lot of contamination. So you do more air change per hour, you will replace more times, you will do the replacement. Okay, the fresh air. If you go to say for example in office area, say for example very say for example in general spaces, it is very less contamination. Okay, so that is why we go with the 4 air change per hour. Okay, but if you go to bank, there are a lot of people moving around in and out, so you have a 4 air change per hour to 10 air change per hour. If you go to the bakeries, you have a lot of smells. Okay, bakery smells and uh, a lot of there is a contamination. Maybe it's not a good contamination or bad contamination, but inside the bakeries you have a lot of contamination, smells, everything. Okay, so that is why you do 20 to 30 air change per hour. Okay,
Authorization.
and if you go to some other area like dark rooms, you have a contamination. If you go to computer room, you have a contaminations, because computer room you should maintain proper indoor air quality. So that is why to remove the dust or something like that, you are going to have a proper air change per hour method. Okay, so if you go to toilets, you have a smells, so you do 6 to 8 air change per hour. Okay, if you go to warehouse, depends upon the materials what you store, you will have a proper air change per hour. Okay, so this is one of the method. Okay, if you go to standard, ASHRAE standard. See for example if you go to fresh ASHRAE, say for example 62.1. So this is the standard for ventilation for acceptable indoor air quality. So what is acceptable indoor air quality? To remove this contamination, correct? Say for example you have a lot of contamination inside the space, depends upon different application. Maybe if you see the home, you have a less contamination, but if you go to office area, you have a much more contamination because there are a lot of peoples. But if you go to barber shop, if you go to bar, if you go to chemical factories, you have a different contamination. So if you go to 62.1, they are telling you that what is the ventilation for acceptable indoor air quality to maintain indoor air quality, right? So to maintain proper indoor air quality, what is acceptable ventilation you have to provide. So that is what this particular standard, which is 62.1 2016, or you have a 2020 or 2019 2022, you have a different standards. Okay, and if you go further down, here also they explain about About contaminant sources, okay, contaminant concentration. There are different contaminations, okay, and you will also do air change per hour method. You will also do air change per hour method to provide proper ventilation, and also you will use 62.1 standard, depends upon the applications. Okay, when you go to this particular spaces, okay, you have a different spaces, right? So you have a minimum ventilation rate in breathing zone. Okay, there are different applications. You have occupation category, like you have a dry room, day room, or you have a classrooms, okay, or you have a art classroom, or you have a cafeteria, or you have a coffee stations, different applications. You provide different fresh air, okay. And how to calculate the fresh air, that I will explain you. Okay, now also if you go to the other spaces, like
Oh, hello,
yeah,
hello,
Albert, yes, yes,
hello.
yeah, tell me, yes.
Sorry. Bilan, buksan mo yung saglit. 1 minute.
Yeah, see, also you can see that there are minimum exhaust rate. Okay, there are different
Yes.
applications again. If you talk about barber shops, okay, if you talk about dark
Sorry?
rooms, okay, if you
Which
talk about
building?
kitchenaids, or if you talk about pet shops, okay, so here they provide how much
Chicken.
ventilation you have to provide. Clear?
I will call you after 5 minutes. I'm in the
Yes,
meeting
sir.
1 minute.
Okay, so now you can say that there are different applications. Like yeah, first
Now?
we have seen that air
Okay.
contaminants. Okay, then
Bilan
after
number,
that
bilan number 10, right?
to
Bilan
replace.
number 10.
Sorry, there's some disturbance. 1 minute.
Sorry? No. Wait me out outside, brother. I will.
Okay, see now we have talked about air contaminations. There are different contamination inside the space, and to replace the contamination, what is the air change per hour is required to maintain indoor air quality. Okay, and if you go to ASHRAE 62.1, also will tell you that how much of fresh air you have to provide each and every spaces. Okay, so if you go further, if you go to the calculations, okay, here they provide the calculation. You can see here the breathing zone outdoor airflow rate, how much fresh air you have to provide. So what is the formula? VBZ. VBZ is nothing but breathing zone equal RP. RP is nothing but outdoor airflow rate required per person, multiplied by PZ, zone population, the number of people in the ventilation zone during usage, okay, plus RA. RA is nothing but outdoor airflow rate required per unit area as determined from the table 6.2.1, multiplied by area, zone floor area, the net amount, the net occupiable floor area of the ventilation zone. Okay, so this is the calculation to calculate what is the breathing zone outdoor airflow requirement. Okay, I will open one of the schedule. See, if you go to this particular spaces, okay, say for example, you have a residential tower. Okay, so this is one of the project. You have a residential tower. In the residential tower, you have a fresh air handling unit, and you are going to provide for the different spaces. You have a lot of residential or commercial. You are going to provide a lot of spaces. You are going to provide fresh air. Okay, so you can say that there is a fresh air handling unit which is located in either in the basement or in the roof or in the middle of the tower, anywhere you can locate it. Okay, so here you will have a fresh air which is coming from outside, and you are going to provide the fresh air through the FHU, and it will be delivered to the different rooms. Okay, and also you will going to remove the exhaust. Okay, because you have a lot of contamination inside, and you will remove the exhaust from the each and every spaces, and you will take it outside to the building. So by replacing the stale air with the fresh air, so this is what we are doing here. Okay, so now how to calculate the fresh air? That is based on 62.1 method, or you can calculate based on the air change per hour method. There are two methods. Okay, now we will go based on 62.1 method. Okay, so what is the calculation here? You can see that this is the equation to calculate your fresh air. Okay. Now I will also open one schedule. Okay. Now you can see there is one schedule for pressure handling unit. So whenever you see the pressure handling schedule, you will find FAQ reference and location wherever it is located and the unit configuration. Unit configuration nothing but exhaust fan plus total heat recovery wheel plus cooling coil plus sensible heat recovery wheel plus supply fan. Okay, so here if you see the schedule here, you will have a airflow rate which is fresh air flow rate and exhaust air flow rate. Then you have a total heat recovery wheel. So you have a fresh air on wheel, fresh air off wheel, exhaust air on wheel, exhaust air off wheel, and you have a cooling coil which is you have a on coil, then you have off coil, then you have a capacity, sensible capacity, then you have a chilled water inlet, chilled water outlet, then you have a chilled water flow rate, then you have a sensible heat wheel where you have a treated fresh air on wheel, off wheel, then you have a exhaust on wheel, exhaust off wheel, and then you have some other electrical data. Okay, so whenever you see the fresh air handling unit which we have seen just now, you will see like you can say that there is a FAHU here, then you have a supply fan, then you have an exhaust fan. Okay, then you have cooling coil. This is the cooling coil here, and this is the thermal wheel. Okay, you will have a thermal wheel, you have total heat recovery wheel, or you have a sensible wheel. Sometimes you have a heater, sometimes you have a humidifier. Okay, there are different components inside the FAHU. Okay, now first of all we are going to calculate how to calculate the fresh air and exhaust air calculation. Now whenever you see the FAHU schedule, you will find first fresh air flow and exhaust air flow, correct? So here you will find 8472 or exhaust air you will find 7472. So how to calculate this airflow rate? There is Excel sheet here. So in this Excel sheet you can find this is the minimum ASHRAE requirement, okay, which is 62.1. Okay, so what you are going to calculate, you have a different spaces. Okay, you have a level or you have a different spaces, whatever the spaces, you can enter the value here. And also you can enter different applications here. You can say different application as per ASHRAE 62.1. Clear, Jeffrey? Ijaz,
Yes, sir.
Albert, you are getting right what I am
Yes, sir.
trying to say.
Yeah.
Okay. So first we are talking about contaminants. There are contaminants inside the space. Why there is a contaminant? Because you have a air conditioning system which you have always recirculating. When you try to do complete recirculation, you have a lot of contamination inside. So what are the contamination we have seen? Like you have a dust, or you have a bacteria, or you may have smoke particles or tobacco smoke, or whatever the smokes or any volatile organic components. Okay, so these are the contaminants inside. So how to replace the contaminant? Why we have to replace the contaminant? To maintain indoor air quality. Okay, why we have to maintain indoor air quality? For the human safety purpose. If you have a dusty air, you may have a lungs problem, or the person may get sick. So that is why we are trying to maintain the fresh air. So how you maintain the fresh air, or how you maintain indoor air quality? You have a two methods. One is the air change per hour method, and another one is the ASHRAE 62.1 method. Air change per hour method is based on the volume. Okay, you have a total this much volume. Say for example, I have one space. Okay, if you talk about I have office area. Okay, and what is the total square meter? I have, say for example, I have 100 square meter. Okay, and what is the height? I will say 5 meter height. So what is the total volume? 100 multiplied by 5. So this is like 500 meter cube, right? Okay, and for office area, how much air change required? For the general spaces, we have seen 4 air change per hour. So when you multiply by 500 meter cube, multiply by 4 air change per hour, you will get 2000 meter cube per hour, because this is the meter cube and this is air change per hour. So you have a meter cube here and you have a hour per hour here. So you will have a 2000 meter cube per hour. So this is the fresh air requirement. So this is also one of the method. Okay, but as per ASHRAE standard, when you go as per 62.1, they have given depends upon each and every spaces. So that is why if you go to 62.1, you will find different spaces here, occupancy category. You have a cell, you have a day room, you have a daycare sick room, then you have a art class room, you have a restaurant dining rooms, then you have a break rooms, then you have a bedroom living rooms, then you have office buildings, then you have a miscellaneous spaces, public assembly spaces, residential apartment, retail, sports and entertainment. Okay, you have a different spaces. What is the amount of fresh air is required? That is what we are going to calculate. So what is the equation? As I told you, this is the equation here. Fresh air. To calculate fresh air, you see VBZ is equal to RPZ, RP multiplied by PZ plus RA multiplied by AZ. What is RP? Is the number of people. Okay, how many people, like per person, what is the amount of fresh air you have to provide? Okay, RP is the amount of air you have to provide per people, and RA is nothing but how much of fresh air you have to provide per area of square area per area, which is square meter. Okay, and PZ is nothing but number of people, occupants, and AZ nothing but how much area, what is the total area. Okay, so if you go to one of the spaces, say for example, I have a studio, I have a bedroom, living room. Okay, so based on this one, how much fresh air? If I go to ASHRAE, it will tell you that for bedrooms, if you go here for bedroom, living room, what is the fresh air you have to provide per person? 2.5 liter per second per person, and for area you have to provide 0.3 liter per second per meter square. So this is the method. This is the ventilation rate you have to provide as per 62.1. So when you go to this Excel sheet, you will find 2.5 liter per second per person and 0.3 liter per second per meter square. Okay. Now, based on the furniture layout, you may have 2 people, correct? And you have an area which is 36 square meter, that particular room. Okay. So when you apply in this equation, so when you try to calculate the fresh air, it will calculate by number of people multiplied by the outdoor air flow rate required per person. So when you multiply by number of person, you will get total fresh air plus area multiplied by the outdoor air rate required per area. How much? 0.3 multiplied by number of square meter, you will get total fresh air here. So this is for one space you are going to calculate. So when you try to calculate for each and every space, what is the fresh air requirement, you will add each and every spaces, right? You have say for example 100 spaces, because a fresh air handling unit is a huge equipment. You can provide maybe multiple rooms. So when you add all the fresh air here, okay, based on the same equation you have to apply for each and every spaces, then you will come up with the total fresh air requirement. Okay, so this is the total fresh air requirement. So how much fresh air requirement? For example, for the entire space you have 27,775. Okay, and what is the exhaust requirement? The exhaust airflow rate as per ASHRAE, you will provide like 85 percentage. Okay, now if I go to this particular one, okay, when you try to calculate your exhaust here, okay, there are different exhaust here. Say for example, you have a general exhaust here, then you have toilet exhaust here, then you have a pantry exhaust here. Okay, so this all exhaust you have to calculate. Okay, say for example, if you talk about toilet exhaust here, so when you go to ASHRAE 62.1 again, okay, you have a minimum exhaust rates for the toilet. Can you see this particular table? For example, you have a public toilet or private toilet. Okay, so if you have a public toilet or private toilet, you have how much of exhaust is required per WC or per urinal. Say for example, if you have a private, you have to take exhaust of 12.5 liter per second per unit. So what is the unit? You can see table E and H. Okay, so if you talk about E, the rate is for toilet room intended to be occupied by one person at a time. Okay, and you can see that rate is per water closet or urinal or both. So whenever you have a toilet, say for example, uh, assume that this is your toilet area and you have different WC here. Okay, this is one WC, this is one WC, this is one WC, and this is one WC. Like that, there are different WCs. Okay, you have a toilet rooms. Okay, so each and every room, how much exhaust you have to take? This is based on the ASHRAE 62.1. If you have a public, you have to take 25 liter per second. If you have a private, you have to take 12.5 liter per second. So when you go to this particular table, it will also calculate how much exhaust you have to take. Say for example, fixture quantity. So per fixture quantity, how much exhaust you have to take? 12.5 liter per second for the toilet exhaust. So when you take 12.5 multiply by the WC, how many WC you have? Okay, how many fixtures quantity you have? So like I have one fixture quantity, or I have two fixture quantity, or I have three fixture quantity. So based on that fixture quantity, it will calculate your fresh air, how much fresh air you have to take, or how much exhaust you have to take per place. Say for example, if you talk about this particular area, okay, you have 12.5. Okay, you can say that there is a 12.5 multiplied by 1, you will get total how much exhaust air you have to take. Then also you have to calculate pantry exhaust. In case if you have a pantry, say for example, if you have a bedroom, okay, this is your bedroom, or you have a studio hall, for example, this is your bedroom and this is your toilet. Okay, and this is your, say for example, this is your bedroom and this is your toilet, for example. Okay, so when you have a fresh air, this fresh air is for the based on the people, okay, or based on the area here. But when you talk about exhaust air, the exhaust air is for the your toilet, how much per WC based on that, and also if you have any pantry exhaust, okay, and also you have to provide your exhaust air. Okay, so this fresh air will go through the toilet and also it will go through the pantry, say for example. Okay, so then you have to calculate the fresh air here and you have to calculate the exhaust air here, and whichever is higher, because you have to maintain positive pressure here. Why you have to maintain positive pressure? Because the smell from the toilet should not go into the bedroom, and also the kitchen smell should not go into the spaces. So you have to maintain positive pressure here. So when you maintain positive pressure, that means the fresh air should be higher than the exhaust air. Correct? So that is why then only you can create a positive pressure, and then here you will create negative pressure. When you create negative pressure, that means here you have a more air outside going than which is coming inside here. So that is called maintaining negative pressure here. Okay, so by using this equation, you can calculate each and every spaces. Like for example, if you have a studio and you have bedroom here, and for the bedroom, what is my fresh air requirement for based on the people, 2.5 liter per second, and based on the area, I will calculate per meter square. Okay, then I have an area here and I have a number of people here. So based on that, I can calculate 15.8 liter per second fresh air. Okay, and what about the exhaust? I have one toilet here, and for that toilet, I have a 12.5 liter per second. So this is my exhaust. Okay, and this is actually in CFM. So you are just converting into CFM. So this is the way you calculate your fresh air and you will calculate your exhaust air. Okay, you have any doubt, Jeffrey or
No, sir.
Ijaz? Okay, see now for example, if you go to this particular schedule which I have shown here, this is the fresh air handling unit schedule. Okay, we will see each and every item. Okay, but first you have to calculate your airflow rate, fresh air airflow rate, and you have to calculate exhaust airflow rate. So here to calculate exhaust airflow rate and fresh air airflow rate, you see one of the application where I have fresh air here. I'm going to supply to different spaces. Forget about the airflow rate here or deck sizes. Just to see that fresh air handling unit which I am serving to different spaces. Okay, I have a tower building, I have a level different levels here, and I have a different apartments inside the spaces, and I will be supplying to different spaces. Okay, so how much space, how much fresh air is required? Say for example, I have a fresh air, I will say 85 liter per second, and here exhaust 75 liter per second. So this is going to multiple apartments. Okay, so each and every this is going to particular floor. I have multiple apartments. Okay, so it will be supplied to multiple apartments. So each and every apartment, how much? If I go here, I have a level 1 studio, level 1 another apartment. I have another apartment. I have another apartment. So each and every apartment, I have a 36 square meter, 28 square meter. Then I have a 30 square meter. Clear? So when I add the fresh air here, for example, if I calculate the fresh air for the bedroom, I need 15.8. Then I need a fresh air for kitchenette, I need a 48.6. So when I add all together, maybe I will get 77.8 for that particular apartment here. Then another apartment, another set of apartment, I may have 106. Another set of apartment, I have 95 liter per second. So like that, I will be calculating the fresh air. Okay, and the exhaust air will be calculated based on the toilet or kitchenette or general spaces. If I have general spaces, I will be calculating based on 85 percentage. Okay, say for example, I am supplying 48.6 fresh air, for example, liter per second. So if I have to calculate the exhaust air, I have to create negative or I have to create positive pressure. So how to create positive pressure? I have to keep my exhaust 85 percentage lower, for example. Okay, say for example, I have 50 liter per second. Okay, then I have to calculate my exhaust, which is 85 percentage of my fresh air. Okay, so because I have to create positive pressure and I have to create negative pressure here. Clear? Okay, so this is the way I calculate all my fresh air. So when I calculate for all the apartment, I will be coming up with total this much fresh air and this much exhaust air. Okay, when I multiply by different FHU, because in one FHU I cannot provide 27,000 liter per second. It's a very huge FHU. Maybe I don't have a proper structural to carry this much FHU. Maybe the FHU manufacturer can manufacture a big FHU, but that FHU cannot place it in the roof because your structural load will increase. So for that, what I'm going to do, I'm going to multiply with the different FHUs. I'm going to split into different FHUs. So one FHU will be serving to one particular area. Say for example, I have one apartment here. This is a complete building. Okay. So what I'm going to do, I'm going to keep one FHU here. I will be serving for this area. I will be keeping one FHU here. I will be serving this area so that I can split my FHU and also I can split my FHU capacity. Otherwise, instead of going with a very bigger FHU, my structural load will increase. So if I split the FHU, then my structural load can be optimum by splitting the FHU here. So that is why if you see some of the project, you have a multiple FHUs. So if you go to for this particular schematic, you will see different FHUs. So this FHU serving to this particular apartments, and this FHU serving to this particular apartment, and this FHU serving to this particular apartment. We are going to split. Why you are going to split? Because to reduce the capacity. If you increase the capacity, your structural load will increase. So that is the way you can plan the FHUs here. Okay, and I will be showing you one of the sample calculation here for different projects. Okay, here also you also can see that ventilation summary. Okay, this document I will be sharing with you. You can see that room name. There are different room names here: pump station, IDF room, furniture store, accessible store, and I have an area here. This is based on the furniture layout. I will take the area and I can take the height and I will take the volume. How much area multiply height? I will get the volume here, and I have ventilation as per 62.1. Okay, 62.1 fresh air. So now I have a liter per second per area, like ASHRAE 62.1. I have a liter per second per square meter. That means based on the area, how much 0.3 for this particular space. If I go to 62.1 for this particular occupancy category, I have to supply 0.3 liter per second per meter square. This is square meter. Okay. And if I go to some other rooms, like say for example, I have a back of house room, I have to provide 2.5 liter per second per person. Okay, how many person? I'll be having occupancy. How many person here? This is like a 3% or 5% or 1%, depends upon the application or depends upon the furniture. So when I calculate my fresh air, how I will calculate? By using that equation. What is that equation? Liter per second per meter square multiplied by meter square area. So I will get total fresh air liter per second plus for the occupancy liter per second per person multiplied by number of person. I will get how much liter per second required for the people. So when I add together, I know what is the total fresh air requirement. Correct? So then when I multiply by 0.85 percentage, I will get exhaust air. Okay, so that will create my that will create either you can if you provide, say for example, if you want to provide one room, okay, and I have toilet here and I will be having a pantry here and I have room here, for example, hall. So I am providing fresh air here. So whatever the fresh air can go through this particular space and go through this particular space, I can make it neutral, for example. Okay, in case if I have one room, common one room, in this particular room I have to create positive pressure. So what I will do, when I take the fresh air, when I supply the fresh air and when I take the exhaust, I can take 85% here. Okay, so I can make it neutral or I can make it positive pressure or I can make it negative pressure, depends upon the occupancy or depends upon the application. Okay, or depends upon the type of rooms. Okay, so by providing here, I can add like how much fresh air for the space. I can calculate how much exhaust here. So when I add all the total here, okay, when I add all the total, I know what is the total fresh air requirement. Okay, see here, for example, you have a different tables for different rooms. All are same equation for different rooms. Okay, so I will be calculating all fresh air for different rooms. Clear? So this is the Excel sheet which I am sharing with you, how to calculate the exhaust air. You can also practice this fresh air calculation. Then by calculating this fresh air, you can able to calculate what is the total pressure requirement and what is the exhaust air requirement.
Hello,
clear,
engineer.
Jeffrey? Yeah. Yeah. Yes, Albert. Yes.
Yeah, engineer. One question only. For calculating this one, normally we're doing this positive pressure, right? For example, for the building like this.
Depends upon the application. See, for example, if you are in bedroom, so in the bedroom, you have to see that what is the pressure you have to create. Can you tell me what pressure you will create in the bedroom?
Should be positive pressure.
Okay, why positive pressure?
Because when you because for example, engineer, in the toilet it is positive pressure. There's a tendency that the smell will
that smell should not come into the space. Correct?
Yes.
Yeah, that is why you create positive pressure. Also, you say for example you have a window. Okay, so when you try to open the window, if you create a positive pressure inside the space, that means all the air will be leaked outside. Correct?
Yeah.
So that means no dust will come out from outside to inside.
Yeah, but for this one, engineer, which specific area that we need to maintain this neutral pressure?
See, neutral when you can maintain. Just now I told you. Say for example you have one space. Okay, if this is one space here, and you are going to provide fresh air, and then you have a toilet here, and then you have a pantry here. For example, okay. So here you are going to create a positive pressure. How you create a positive pressure? Because you are pumping the air into this particular space, right? You are not going to take any exhaust here. So this particular air will be positive. Okay. And when you take the air from here you will take always exhaust, right?
Yes. Yeah.
So here you will create negative pressure.
Yeah.
Okay.
Yes.
So when you create a negative pressure, it will try to suck the air from surrounding space.
Yeah.
Okay. And also when you have a pantry, no, not outside. This is a hall. This is a hall.
Yeah. From the gaps of the doors like this, right?
Yeah, through the door or through the gaps, right?
Yes.
And here also it will go through the pantry. Pantry means it will take the exhaust, but from where the air will take, it will take from here. Correct?
Yeah, correct.
So that means you are pumping the air and you are taking the air here. So here you no need to create a difference in air flow rate. So if you have 100 liter per second, you're going to take out 75 liter per second here, 25 liter per second here. So automatically you are creating positive pressure and also you can make a neutral airflow rate. Clear?
Okay. Clear.
Okay. Assume that you have one space. I have one bedroom only. So I'm going to take one supply air and I'm going to take exhaust air. So in this case, yeah, I'm going to supply 100 liter per second, then I cannot take 100 liter per second here because it will be neutral. So I have to
Yes.
create positive
Should
pressure. Yeah,
Okay.
yeah. So then you make it 85% here. Correct.
85. Yeah. Correct. Yeah. Yes.
So this is each and every space. See, the formula is common. Okay, for each and every spaces. So what is the formula as per ASHRAE 62.1? I told you here. So this is the
Yes.
equation. Okay, so this is the equation as I told you. This is the equation here. The same equation you are going to use it for all the applications. Okay, all the rooms. If you talk about each and every studio, each and every bedroom, you are going to use this equations here. Right? Say for example, if I have a
Okay.
fresh air, I have a fresh air. I'm going to use this equations here. Say for example, this is the equations, right? So what is the equation? You can see the occupant, number of occupants multiplied by outdoor airflow rate required per person. So it will give you fresh air. And for the area,
Yes.
okay, why the area you are providing? Because say there is no people, but still you have to provide fresh air to maintain indoor air quality or to avoid any smell or to avoid any dust inside the spaces. That is why you provide area. Okay. Sometimes say for example you have a electrical room or plant rooms or some closed rooms, closet. Okay. So there is no people. So there you have to provide based on the area. Correct.
Correct.
Okay, so that is why always whenever you provide the fresh air, you will provide fresh air for the area and also you will provide fresh air for the people. Okay, so that is the
Right.
total
Sir,
fresh air requirement.
I have one doubt. This
Yeah, tell me. Yes, yes.
like sometimes they use the word outside air and fresh air. Like, what is the difference?
Both are
Like,
same. Both are same. Both are
both are
same.
same, right?
Yeah, because fresh air means the fresh air cannot be indoor air, right? Because it is a
Yeah,
recirculation air. When you say fresh air, it comes
yeah.
from outside. Fresh, which is fresh, means from outside. So sometimes they say outdoor air or sometimes they say fresh air. Okay, or sometimes they say
All right.
ventilation. Ventilation is also is
Yeah.
nothing but the outside air.
Okay.
Okay, so here you got idea how to calculate fresh air and exhaust air.
Yeah.
Okay, so this is your equipment schedule. You will find equipment schedule. You can see that fresh air airflow rate, and also you will find how much exhaust airflow rate, right?
Correct.
Okay, so
It's less.
yeah, tell me. Yes.
Yeah, no, I was saying comparing it, like how much it is less. 8472 and 7472.
Yeah,
Like
see, it does.
1,000.
See, it doesn't mean that it should be lesser. Doesn't mean that it should be lesser. It can be more also. Maybe I will show you some spaces where it is more. For example, yeah, can you see this one? The fresh air is less, but exhaust is more. Correct?
Yeah.
It doesn't mean
Yeah.
that it is always 85%. It depends upon the application. Say for example, if I go to one, if I have a more KitchenAid, for example, I have a more KitchenAid here. So that means I have a more exhaust, right? Then I have
Yeah.
say for example, I have only 5 bedrooms, okay, but I have a 10 10 kitchens and 10 toilet. What will happen? I have more exhaust and I have a lesser fresh air. Okay.
Yes.
So it
Yes.
doesn't
Yes.
mean that always fresh air should be higher and doesn't mean that always exhaust air should be higher. No, it's not like that. It depends upon the application. Okay. So if you see this particular formula, what I made, this particular formula is based on the bedroom. Okay. But when you talk about this exhaust air flow rate, it is calculated based on the fixtures, toilet fixtures here, right? Okay. And here also you can
Yeah.
see here, this is what based on the area multiplied by area. Say for example, if I go to 62.1, if I go to 62.1 exhaust flow rate, can you see this particular application? For example, KitchenAid. Okay, can you see this one? What they are saying? 1.5 square meter per area, 1.5 liter per second per area. When you have a KitchenAid.
Yeah.
Okay, so if I go here for KitchenAid, I have 1.5. When I click KitchenAid, it will automatically come 1.5 because this is formula which is taken from ASHRAE. Okay.
Okay.
So when I multiply by area, so how much it is? 42.5. Correct.
Yes.
So this is the exhaust air flow rate, and this is the fresh air flow rate. Okay, this is as per calculation. Okay, so here you can see that I'm creating positive pressure inside the bedroom. Okay, and whatever the air from outside, it can go to the through the toilet and through the kitchenette. Okay, so when I have a fresh air in the bedroom and I have exhaust air through the toilet and kitchenette, I can make it neutral. That's what I'm saying, right?
Yeah, but this one, engineer, is just a minimum only, right?
Yeah, this is the minimum. This is the minimum. Whatever we are calculating as per 62.1 is a minimum requirement. Okay, but it you no need to provide much more extra. No, it's not required to provide. Okay, but assume that I have a kitchenette, I have a kitchen hood. For example, I have a, remember that whenever you go to the kitchen, you have a kitchenette or kitchen pantry, the hood, kitchen hood. Okay, so when you check as per the manufacturer, they may say I need 50 liter per second, or I may need 65 liter per second, or I may need 100 liter per second. Depends upon the product you're selecting. Okay, based on that you have to adjust your fresh air airflow rate and exhaust airflow rate. Clear?
Okay, clear.
Okay, so this is the Excel sheet. Try to
Even for example, engineer, your FCU capacity is, let's say, 100 LPS,
Mm.
and then you calculated the fresh air for one bedroom, let's say 25 LPS,
Okay,
and then for the exhaust, it is 85%, right? Of the
yeah,
fresh air.
85%. Yes.
So from this state engineer, you can just simply adjust the fresh air, depends on what percentage you want to be
See,
pressurized, right?
normally as the standard, you have a 85%. Okay.
Okay.
Some engineer they will apply 90%. Some engineer they will apply 95%. Depends upon the contamination. Okay.
Okay.
If you expect more contamination, apply 85%, so that you have like a more positive pressure inside the space. Okay, so that the contamination will not come inside. If you see that the lesser your spaces surrounding with the less contamination, then you can go up to 85%, or you can go up to 100%. Okay. Okay, but you have to see that where you have to apply 85, where you have to apply 90, where you have to apply 95, where you can apply 100%. That is depends upon the application and depends upon your practice. Okay. So when you calculate all the fresh air and when you calculate all the exhaust air, you will come up with the total fresh air requirement for the building. Okay. But what is the why we are splitting the FHU? You cannot go with one FHU. Maybe you have a very big FHU where you have a very huge weight and your structural cannot carry that load. So that is why you split into multiple FHU to neutralize the structural load. Okay.
Okay.
Clear. And you have the exhaust air flow rate and you have the fresh air flow rate by using the ASHRAE 62.1. In case if you don't want to use 62.1 and if you want to use air change per hour method, there is another table. You can use that air change per hour method. Clear? But if you go to any consultant, if you go to any standard consultant, they will use as per 62.1 standard. Okay, and they will be using this Excel sheet to calculate what is the total fresh air requirement. Okay.
Okay.
Clear. And we will see in the next class. Maybe the next class we will continue next week, and I will be explaining you how to calculate what is the purpose of thermal wheel and what is the purpose of horseshoe pipe and what is the purpose of heater and what is the purpose of humidifier. Okay, and what is the purpose of cooling coil as well. Okay. See, there are two types of air conditioning. One is the treated fresh air and another one is the untreated fresh air, right?
Yes.
Okay. So when you say untreated fresh air and when you say treated fresh air, what is the requirement? We will calculate in the next session. We will see. And by for this particular week, I'll be sharing you one video. Just watch that video, and also I'll be giving you some. You can also try to practice some calculation for small rooms. You will take 5-6 area and try to calculate what is the total fresh air and what is the total exhaust air. Try to calculate. Do that practice. Then we will continue. You will get practice, like you will get idea how to calculate the FHU capacities. All right.
Okay, engineer.
Yeah.